Hi guys, today I'll walk you through the Maths A-Level Pure 1 exam from 2021. Question 1. As x minus 1 is a factor, then it has to equal 0 in the case of the function. Therefore, if x equals 1, the function should equal 0. Then when you sub in the x, you get this, which simplifies to a plus 10 minus 3a minus 4 equals 0, which is the same as minus 2a equals minus 6, therefore a equals 3. For question 2, part A, you just want to complete the square. So in this case, it will be x minus 2 squared minus 4 plus 5 equals 0. So x minus 2 squared plus 1 equals 0. In this case, then a would be minus 2 and b would be 1. As stated in the equation. For part B, I, P is the point where it meets the y-axis, which is when x equals 0. When you sub in x in the function, it leaves you with y equals 5. So 0, 5. For I, you just get the turning point from the completed square, which is 2, 1. Question 3. It's a sequence question, so for part A, we want to use the equation here given to find u1, u2, and u3. So u1 would be 2, as it says. u2 would be k minus 12, subbing into the formula. And u3 would be k minus 24, k minus 12. Then using the formula given, we do u1, which is 2, plus 2u2, which is k minus 12, plus u3, which is k minus 24, k minus 12, equals 0. Then we simplify this, which is 2 plus 2k minus 24, plus k minus 24, k minus 12 equals 0. Then we simplify further, which would make it 3k minus 22 minus 24, k minus 12 equals 0. We can multiply everything by k minus 12, which would be k minus 12 then we expand the brackets, which would be 3k squared minus 22k minus 24 minus 36k plus 12 times 22 equals 0. Then simplifying this, it will be 3k minus 58k minus 24 plus 264. Then we simplify further, which would be 240, which is the same as the example given, so that's the right answer. For part B, we can just use the quadratic formula to find k, and it's obviously gonna give us two answers, so we should choose which one is the right one. So using the calculator, it gives us 40 over 3 and 6. However, the right answer is 6, as it says it's an integer. So we cross out the 40 over 3 and it's 6. And lastly, for part C, you just want to use where u3 is as equal to k minus 24 over k minus 12. Then if k equals 6, you just sub it in, which would give us 6 minus 24, 6 minus 12, which is 6 minus 4, which is 10. Question 4. For part A, you just want to differentiate the function and set it equal to 0, as then that will be a turning point, as it says. So differentiating this, you'll give us 2x plus 1 over plus 5 times the differential of the brackets, which is 4x minus 4. Therefore, that will be over 2x squared minus 4x plus 5. Now setting it equal to 0 will give us this, and solving for x, you can just multiply both sides by 2x squared minus 4x plus 5, which would give us 4x cubed minus 8x squared plus 10x plus 4x minus 4 equals 0. Then you can simplify that, which would be 4x cubed minus x squared plus 14x minus 4. Then dividing it by 2, as it's a common factor, you can just take out 2. Will give us 2x squared minus 4x cubed squared plus 7x minus 2, which is the same as the one given. For part B, you just want to use the formula given, and as x1 equals 0.3, x2 would be just x1 subbed into this formula, replacing xn with x1, which would give us 0.3294. Then doing the same process, we can find x3, which is 0.3375, and finally x4 would be 0.3398. So we got solutions to both of these. Lastly, for part C, we want to show that alpha is 0.341 to 2 decimal places. So we can do that by taking the upper bound, which would be 0.3415, and the lower bound, which would be 0.3405, and subbing those in the formula given here. In this case, that would give us a positive number, and that would give us a negative number. So the change in signs indicates a root, so we should stay there. Change in signs is indication of a root, given that the function is a continuous one. Is continuous. And we should state both these statements as it says in the question. Suitable function. It should be continuous. Question 5. Here for part A, we want to use the geometric sequence equation, which is n minus 1. So in this case, the profit will be equal to the 20,000, which is the initial value, times the percentage increase, which is 8%, times n minus 1. Therefore, in year 3, the profit will be 20,000 times 1.08, 3 minus 1, which in this case would be equal to 23,328 pounds, which is the same as the one given. So for part B, we want to use the equation which we made in the part A, and so 65,000 should be less than the profit made, as it's going to be exceeding it. Therefore 20,000.08 n minus 1. In this case we can just solve for n by doing 0.08 n minus 1, 65 over 20,000 obviously. Then if we take logs from both sides, we get 65 over 20, which would be n minus 1. Therefore plus 1 would be n, and in this case n would be 15.3, therefore has to be 16. That's the first year in which it exceeds, and as in the first year it's 20,000, we just add the 1 year to make it 17. As in 16 years, that will be the 17th year. So lastly, for part C, we want to use the geometric series equation as it wants the total profit. So you have to find the sum of each one, and the equation will be Sn equals a 1 minus Rn 1 minus R, as in this case a would be 20,000, because that's the initial value, and R would be just a percentage increase each year, as that's the difference, the ratio. Therefore, by subbing in the sum for the first 20 years would be 20,000, 1 minus 1.00 to the power of 20 over 1.1 minus 1.08, and in this case that will give us 915,239, which to the nearest thousand would be just 950,000 pounds, of course. Question 6 is a vectors question. So for part A, we want to find the one which follows AC. Looking at the diagram, that will be this one, going from A to C. So as we know, AB as is given to us, and BC is given to us, we can just add both of them. AB plus BC, that would give us AC. So in this case that would be minus 3i minus 4j minus 5k plus I plus j plus 4k, which would be minus 2i minus 3j minus k. For part B, we want to show that cos ABC is 9 over 10. So in this case, we want to show that this angle, as the middle letter is B, so is this one, is cos 9 over 10. We can do that by finding the lengths of each side. So in this case, AB would be the square root of 3 squared plus 4 squared plus 5 squared, which would give us 5 over 2. BC would be the square root of 1 squared plus 1 squared plus 4 squared, which would be 3 over 2. And as we found AC from the last part, we can find its length using the same method, which would be 2 squared plus 3 squared plus 1 squared, which will give us 4 plus 9. The square root of 14. So if you label it BC is 3, 2, then we can just use the cosine rule, which would be a squared equals b squared plus c squared minus 2bc cos a. Therefore, 14 squared equals 5 over 2 squared plus 3 over 2 squared minus 2 b c cos a. Then solving for a, solving for cos a, you'll give us 9 over 10, which is the same one as the one in the question. Question 7. Here it's a circles question, so for part A, the first part, we want to find the center. We're going to find this by putting this equation in terms of a circles equation, which will look like that. So we want to complete the square for each term, x and y. So by doing this, we get x minus 5 squared minus 25 plus y plus 2 squared minus 4 plus 11 equals 0, which simplifies to x minus 5 squared plus y plus 2 squared equals 18. Therefore, the first part of the question, the center, would be 5 minus 2. I'll just take, well, we just take the opposite from the brackets. And therefore, for part 2, the radius would be just the square root of 18, as those two correspond to each other. The square root of 18 can be simplified to 3 to the square root of 2. For part B, it says that this line only touches it once. It's a tangent. That means it's only touched once. Therefore, it would suggest that the determinant of the solution of the two equations will be this, as it's a tangent, so it's only touching once. So there's one root. So if we solve those two simultaneously, we will get this. Therefore, by simplifying, we get minus 10x plus 12x plus 4k plus 11 equals 0. This simplifies to 10x squared plus 2x plus 6xk plus k squared plus 4k plus 11 equals 0. By putting this into the quadratic formula style question, we get x plus k squared. Therefore, this would be C, this would be B, and this would be A. So subbing it into this form, it will give us squared minus 4, 10, has to equal 0 as it's only touching once. Therefore, this will be plus 36k squared minus 40k squared plus 1 minus 160k minus 440 equals 0. Therefore, this will be minus 4k squared minus 136k minus 436 equals 0. Therefore, by solving this, we get k is either minus 17, 6, or so those are the two possible values of k. Question 8. Here, we're given this equation and those two statements, which we can use to find the complete solution. Firstly, as n is 100, 1000, at the start, that means when t is equal to 0, and at t equals 5, it's doubled, so n equals 2000. Then we can sub those into the equation and solve it simultaneously. Therefore, and this would give us 1000 equals a to the 0, which is basically just 1. So a is 1000. Therefore, we get this, which is basically E5k equals 2. Taking logs of both sides, we get log of E divided by 5 equals k. Therefore, k would be k would be 0.139. So putting those back into the original equation, we get n is 1000 E times 0.139. So we get this. Then the next part, it says find the rate. So it wants us to differentiate it. Therefore, as n is equal to 1000 E open, then dn dt would be 139 E over 139 t. And exactly after 8 hours, so when t is equal to 8, that would make dn over dt be times 8, which is 422.62, which is 420, the two significant figures. Lastly, for part C, it says that this equation represents the second population. So m is E 1.4 kt. However, it says k is the same as from part 1, so we can just replace it with that. And the other one, the other population, is represented by the equation of E 1.39 t. Therefore, they're the same at a given time, and if we want to find this, we have to make them equal to each other to be able to find t when they are equal. Therefore, equals to 1000. Here they're equal to each other. We can divide it by 2 to simplify, which will give us this. Then if we take log of both sides, we get log of e is this. Therefore, we can, using log rules, we can separate the first bit by doing log of e to 2 plus log of e to the 1.39t, which is still this. Then this becomes ln of 2 plus this can be just moved to the back and those two cancel each other. Therefore, we're only left with this. Then by rearranging, we can find t, which would be minus ln 2 divided by which gives t, which in this case would be 12.47, which is 12.5 hours.